Good day, everyone. We are looking at first order differential equations in math 6. So this problem says we should find the particular solution of dy over dx minus 2y cot x is equal to the function on the right hand side. So when it comes to first order differential equations in math 6, there are only two formulas that you need to use to help you out. So they are on page number 7 of the formula sheet. I'm looking at my formula sheet. If you are an N6 student, you go to page 7, start counting from the bottom. You will see formula number 5 if you are counting from the bottom. So the first formula is written like this: dy over dx plus p times y is equal to q. This one we call it the general form of the formula, or of the general form for the equation of first order differential equation. Then the next one, which is just close to this one, is written as y e to the power, the integral of p dx is equal to the integral of q times e to the power, the integral of p dx, then dx. So these are the two formulas that once an N6 student can know how to make use of them, then you are done with first order differential equations. So the first formula is called the standard form of a first order differential equation, which means each time I'm given a first order differential equation as I see here, I will try to arrange it to look exactly like this. So to look like this means there are two terms on the left, the first one being dy dx, followed by a certain function p that is multiplying y, and the rest on the right are q. So we'll try to do that on our problem. So looking at our problem, I'll be matching, comparing the first term. The first term, you see they're exactly the same. It means the first term, I don't have any trouble here. It's just going to be written exactly the way I see it, because it's a perfect match for what I see there. Then the magic comes here, or the trouble comes here, where after dy dx you are seeing a positive sign, but you see your equation has a negative sign. So I want to show you how do you manage that. So what I'll simply do is I'll put the positive sign as requested by the formula. Then that negative sign I see there, I will create a bracket for it. Then I push that negative sign to follow this number into that bracket. So what I'm putting in here is negative 2 cot x, because you know the second term must have something multiplying y. So if I want to plug off this y, you see what is left. So because what is left has a negative and not a positive, I'll put my positive, I create a bracket for that, then I put my y outside. So when I look at this problem now, it's exactly like the left hand side. So I've seen my dy dx, I've seen my positive sign, I've seen my p. So what you put in bracket, you will call it your p. Because the purpose of the standard form is to create p and q. Then on the other side, whatever is left, whether there are 20 terms, 10 terms, 5 terms, they stay on the right, they will now form your q. So this problem, it wasn't so much of a challenge seeing p and q. The only issue here was to make sure you know how to bring this positive sign in the place of the negative sign there. So on the right, this is my q. So that is the first thing you do with a first order differential equation. The target is to create your p and your q. So now that we have succeeded with that stage, especially when I'm creating my p, I must make sure I see this positive sign just like it is here. So now that we've created your p and q, the next step, what is expected of you is to take your p and q into the next formula. If you look at the next formula, you see there is p and q appearing there. And then you solve the two simultaneously, which is usually not easy for many students. So the best way I advise students to do this, to continue with this problem, is to split this formula into little bits. So I'll start by doing this portion only that contains p, and you can see that portion appears on both sides of my formula. So it's like I will cut it off and handle it. So if I cut it off, that simply means I'm doing the integral of p, which is the integral of, you can see what is our p. Our p is negative 2 cot x. So all constants, I take them outside. So I'm simply integrating cot x dx. So the integral of cot x is on page 2 of our formula sheet, if you don't know. So I'm going to verify the integral of cot x on page number 2. So on page 2 of my formula sheet, I can see cot, then I use column number 3. So the integral of cot ax is giving me 1 over a in sine ax. So a is the number attached to x, so that's the number there. So I'll put negative 2 ln sine x. So that is my integral of p, as simple as that. So it means in this second formula, I can say I'm done with the integral of p. So the next target now will be to do this other portion, which I'm putting in a rectangle, which is a very, very important calculation you must know. It even has a special name called the integrating factor. You always see it called IF. So by definition, IF is e to the power the integral of p dx, which is equal to, so I've captured the integrating factor, which appears on both sides. And if you look at it very well, the exponent is done already. The integral of p is done already. So I've done it already. It's right here. So I just copy from there and paste. So this is e to the power the integral of p dx. We've done it already to negative 2 ln sine x. So that's my integrating factor. So the integrating factor doesn't end there. It needs a little bit of knowledge of laws of exponent and logarithm to simplify this, which I'll try to explain here. So one thing you must know about log and exponent is that if I have e to the power ln 5, for example, if you try this in your calculator, your answer will be exactly 5. So it is as if we can assume that e will cancel ln for us to get 5. So this is an expression, this is simplification that you are expected to know. But what happens if before the ln there is a number, let's say there is e to the power 2 ln 5. In this situation, you realize that the e and the ln can no longer cancel until you apply a law of log here. If you apply a law of log here, it will move the 2 to the exponent of 5, and it will now allow your e and ln to cancel, and you will see 5 to the power 2, which is the same thing as 25. So if you were to put this into your calculator, you will see 25. 25 is 5 to the power 2. So, but if I'm trying to explain it to you, that is what happens. That's why I said here, e to the power being 5 gives you 5, which means you can assume that e and ln will cancel if they are like that in that relationship. But if there is something, any number, in their way of cancelling, you apply a law of log, the number goes there, then you see e and ln can still cancel, they are left with 5 to the power 2, which is 25. So these are the simplifications about loss exponent that we expect you to know if you really want to succeed in question number 4, or let's say first order differential equations. So that brings us back to this one. So if you look at this problem, you see that your e and your ln were supposed to cancel, but there is something on the way. So we must apply our laws of exponent correctly and logarithms. So this will be e to the power the ln of sine x. So I must bring that power to the exponent to become negative 2. So if it goes like that, it now allows e and ln to take care of one another. So I'll be left with sine x to the power negative 2, and that can now give me 1 on sine square x. So that's my f, or my integrating factor. So now that I'm done with my integrating factor, as I've told you in first order differential equations, all you need is to identify p and q by writing it in the standard form. Then when you know them, you bring them to the next equation. So the next equation, we have decided to do it in little bits. We've cut it into smaller bits. So we've done the integral of p, we've done the integrating factor, and our integrating factor is 1 over sine square x. So all we need now is just to take our integrating factor into its position. So if we take our integrating factor into its position, it means we will be putting 1 over sine square in this rectangle, and we'll put it also in that rectangle. That's all we need to do. So we'll try to do that on both sides. So if I go this side, I'll be having my y multiplying 1 on sine squared x. So it means I put 1 on the integrating factor in the place of this rectangle. Then if I go to the right, I will do the same thing. I'll have the integral of q. You still remember our q. This is our q. So I'll copy our q, which is -7, and I'm free to put the negative outside because that is a constant. We don't integrate constant. Then I get 1 minus sine square x times sine square x. That is our q. Then multiply it by the integrating factor. See, the integrating factor is supposed to take the place of this. So if I put multiply by 1 over sine squared x, then dx, then here sine square will take care of sine square. And what am I left with? On the left, I'm left with 1 on y on sine square x is equal to -7, the integral of 1 minus sine square. And 1 minus sine square, if you look at page 1 of your formula sheet, you will receive that 1 minus sine square should just be cos square. So we are simply integrating cos square x here dx. So that is it up to so far. It means the left hand side we have sorted. Our next target now is just to focus on the right hand side. Once you have substituted your integrating factor on both sides, the left hand side does no longer have an integral sign. You are sorted, so we're only left with the right hand side. So we are now going to do the integral of sine square x, of cos square x, sorry, which is on the right. And as an M6 student, the integral of cos square is on page number 3 of our formula sheet. So we go to page number 3 of our formula sheet. To integrate cos square, we'll get x over 2 plus sine 2ax. Our a will be the coefficient of x, which is 1. So simply sine 2x, sorry, sine 2x, all this over 4. Our a is 1. So that is what we get, plus. So if this question was asking us for a general solution, we are going to end. But because they are asking us for a particular solution, it means you need to calculate the value of c. So to calculate the value of c, what do we simply do? We just say x is equal to pi over 3 when y is equal to 3. That is the meaning of this little statement written there. So x is equal to pi over 3 when y is 3. So I substitute there. This will give me y on sine pi over 3 squared. You must also understand how do we put these numbers in the calculator. So you can write sine squared pi over 3 in the calculator is equal to -7 in bracket pi over 3 divided by 2 plus sine. If I put pi over 3 here, it becomes sine 2 pi over 3, all this divided by 4 plus c. So this is what I'm going to do to get my c. Sorry, I'm supposed to have replaced y by 3. So that is basically what we are going to do. So if we carry this one, that side, that will lead us to our value of c. And as an M6 student, we are expected to know that with integration, we must confirm that our calculators are in radians. So I will try to calculate the value of c there. It's 1 on the sine of pi over 3 square in the denominator, then I will say plus, because all of this is crossing to the other side. So I'll say plus 7 into, then I will take my pi over 6 there, 6 pi over 3 divided by 2 is pi over 6. So I take pi over 6, then plus the sine of 2 pi over 3, 2 pi over 3, then divided by 4. So that gives me my value of C as 9,181, and therefore if I need a particular solution, I will get y on sine squared is equal to, that means I will take the value of C and substitute into the general solution, because here is what we call a general solution. If the question was asking for a general solution, we could have ended here. So if I substitute there, I will get negative 7 into x over 2 plus sine 2x over 4 plus 9,181. So guys, that is how easy it is to get a particular solution for the first order differential equation. So I guess this helped you. Thank you very much.